today we're finishing chapter 1, and then Monday's your quiz. Let's see. I want to remind you, if you're going to be late to class, like I said a couple of times in different lectures before, let yourself be late. Step aside, take a picture of your homework, email it to me, see it in your sect folder. It was sent before class started. Take your time getting to class. Who cares? It's the assignment being late that will kill you, not you being late. You can always watch what you missed on the video or whatever. So make sure you get your assignments on time. So now, let's see, the quiz. Open book, open no. Matter of fact, I'll save the quiz for a minute because I want to go back and talk about the spreadsheet I posted last week that I didn't get a chance to talk about from chapter 10. And what I did is I'm encouraging you to do what I did for the EOQ model. Remember, there's 4 inventory models: EOQ, production lot size, and EOQ with shortages, and then I don't think there is a column with product discounts. By ordering more, getting discounts. So these are the 4. What I did, I'm going to click right here so you can see, is I used, if you ever hear the phrase, use cell locations. That's where I have, see it says B3 times B4 divided by, parentheses, B5 divided by 100 times B6. All those cell locations is what I mean. And you're going to have Excel on at least 3 of the 4 quizzes and for sure on your final. And you're going to see a picture of a spreadsheet, and it's going to say, what would you put in cell B13 to calculate the EOQ? Make sure you use cell locations. That's me trying to tell you, don't enter numbers in there, cell location. So that's what I'm looking for. It won't be as hard as this one. But some students have asked, you posted this is done. The correct numbers are entered up here, that this would work perfect. If you finish it yourself, or you have a group study and you guys decide to finish this column, and maybe finish that one, and you want to have this open while you're taking the quiz, before I hand out the quiz, everybody's got to show me they have the internet shut off, phones on airplane mode. But if you want to use Excel to make sure you got the right answer, and if I even said, if you go through all the time on this one, and it's on the quiz, and you put in all those formulas, and then you enter the numbers, and you want to hand this in as your work, I would allow it. Some people want to use Excel. I'm okay with that. But if you didn't use cell locations, you're going to burn yourself here. It's all about that you know which numbers represent which variables, and that it fits in using cell locations in the cell there. If you like Excel and you want to use that, go ahead. Or you can use it at least to make sure you're getting to the right answer, or you get it all set up on your quiz, enter it on here, and then put the answer. You're missing the work from setting it up to the answer, but that's so few points. At least you got an answer there from just off this Excel spreadsheet. That's a half a point right there by even probably attempting the answer. Instead of leaving it blank. That's all I'm trying to say. All right. How I did this is I opened up Chapter 10 PowerPoint. So if you want to do this for those other columns. And then I just follow the formula and set it up using Excel. So I put equal sign, and then I put the square root little function thing, SQRT, parentheses, I put a 2, and then I put the cell location where the annual demand is going to be put, cell location for the ordering cost divided by. So when you're doing this, let's say you're doing it for production lot size, you go to slide 15. Follow that formula in that cell using cell locations. And then notice on Excel, when you get done with this, you should test it. So you got all these cells down here all filled in, the ones you need. By the way, we didn't cover all these. Some of these you're doing in operations management. Like we didn't cover average inventory level, maximum inventory level, so you don't even need to fill anything in here or here, unless they're needed for something else, which I don't think they are, but just the ones we covered, which are economic order quantity, total annual cost is broken up into 2 parts, and then the 2 parts are added here. Reorder point. Let's review reorder point. Reorder point is always the amount of product that the company will go through, whether they sell it or whatever, during the time it takes to get a new order in, called lead time. Let me define lead time. From the time you place an order with the vendor to the time the vendor's truck is pulling up with the order. That's lead time. And the reorder point is always based on the time it takes to get the order in from when it's placed. And then you got to figure out how many you go through during that time. And that's your reorder point. And don't forget, the reorder point over here, where's the reorder point? Oh, you got to be kidding me. Is all about that maximum back order. So if your reorder point here is when we get down to 12, we got to place an order. And you're thinking about a back order policy, and it says maximum back order 2. You're going to be lowering the reorder point by 2, allowing time to go by before you place an order, and eventually you'll be running out, the equivalent of 2, the time it takes to go through 2 before the next order arrives. So that's how you get the reorder point over here. You take the original reorder point that you calculate based on lead time and subtract the amount you want to be put on back orders. Got it? There's your review. Real quick, just again how I did it. All cell locations go here. This is just the holding cost part of total cost. Again, cell locations. Oh, here's what I wanted to mention. See how it's referring to annual inventory holding rate? Some of these problems say 10% of the cost of the item, 20% of the cost to make an item, depending on which one you're looking at. If it says 10%, this is going to be a 10. And then it says here, cost per item, let's say it's the barometers, $50. I think it's 20%, but $50. When you go down here, the formula is taking B5, where that 10 is, and divide by 100, because I wanted to turn it into 0.10, to a decimal, to do the multiplication. That's all I'm doing with that divide by 100. Times B6, 50. Let's pretend, what 10% of 50 is $5. Let's pretend the story says the holding cost is $5. Well then, I'm going to just, in order to force that to be just $5, I'm going to make sure that these two numbers here calculate out to $5 instead of me working with a percentage. So I'll just put, maybe I'll put 100% of $5. Now this should come out to 5. We can't see because we didn't finish it. But that should equal 100 divided by 100 is 1 times B6, which is 5. Now, if the problem says $5 holding cost, it's going to use 5. Holding cost is always in dollars. That's where you got to be careful. I noticed a couple people put 3 cents as 0.3 or 3, when it's really 0.03, because it's got to be expressed in dollars. So it's 0.03 of a dollar, 3 cents. Holding cost. Anyway, so this is posted. You want to work on it before the quiz, feel free, and you can use it. Next, so speaking of quiz, it's only because you're here. I'm not posting this. You got your phones? You do? For a few seconds here while I talk. And let me zoom out. I quickly thought, what the heck did we cover? And I just jotted down a little sloppy. I didn't think I was going to show anybody. Oh, hang on. How do I get this? So I just quickly, let me get out of the way first. Now, like chapter 13, we had 5 basic subjects, you know, the maxi-max, the maxi-min, mini-max regret, EV, which is expected value, EVPI. Chapter 10, those 4 inventory models, EOQ, production lot size, shortages, EOQ, and then quantity discounts. Chapter 1, formulating equations. We read a sentence, but then we focused on reading sentences and turning it into, you know, break-even equations. And today we're going to cover objective function constraints, which is really the building blocks of linear programming. It shocks me that people during chapter 1 and 2 and 3, they all build to get to chapter 4. And if you're missing today these building blocks, how to formulate objective functions and constraints, and you can't really get that, that is in every linear programming problem from this point on. You've got to figure that out. And then Excel, we covered max, min, if, break even using what-if analysis. Do you remember that what-if analysis? That could be on your quiz, where I think there's a picture maybe in that chapter in the book, possibly, but it was, you know, where I opened up that what-if analysis, had a dialog box where it asked me to put a cell location where production would take place I may be asking you on a quiz, what cell location would you tell Excel in the what if dialogue for that thing? So, you know, you gotta be ready for everything related to Excel you learned in the lecture, pretty much. If there's true and false and multiple choice questions, and there's always just one or two or three, that's related to the reading material more. But you should be expecting problems very similar to like you've been having in in-class assignments and homework. Okay? And the key to prepare is that you read a problem, if you can find one random that doesn't give it away what it's about, and you read it, say to yourself, now let's see how long it takes me to figure out where the help is. What chapter is this? Okay, is it chapter 10? 13. Ah, this is an inventory question. It's chapter 10. How long does it take you then to figure out its EOQ or production lot size? Ah, it's got production capacity or production rate. It must be lot size. Where's my formulas? You know it's going to probably ask you for the optimal amount that should be made. Grab that formula, set up the formula, figure out which variables go in there, decide if you got to convert to annual. And that's the process you got to prepare for. Is the time, however fast you can find the help is how much better you're going to do. It's not about memorizing this, it's how fast you can recognize it and then find the help. All right? All right, there you go. Hey. Where are we? We're right here. Right there. Okay. I'm going to give you some definitions about objective function constraints that are very important, because just knowing these important little rules that I'm about to tell you will guarantee you some points and guarantee you not to make a very common mistake. So a couple of common mistakes. Let's start with the objective function. An objective function always has one of two words to start it off. Maximization, abbreviated by MAX, or minimization, abbreviated by MIN. So it's either a max or a min. You have to use common sense to figure out which one of those it is when you read the problem. For example, if it says that this company wants to keep its costs as low as possible, that's the objective right there. And this company wants to keep its costs as low as possible. And you should say, okay, they're trying to keep their costs low, that's the objective, so the objective function must be a minimization. That lines up, logic makes sense, minimizing a cost. Or it may say, and the company wants you to determine the production level of each product next week that will maximize, that will gain the most profit that can be contributed by these products. Well, as a manager, logic should set in and say, okay, it's talking about getting as much profit as possible. That must be a max if that's the objective function that's in the story. So you have to determine, and every objective function has a max or a min. Now, when you've got constraints there, write a note that a constraint always has one of these three equalities in the constraint equation. Less than equal, equal, greater than equal. Notice every one of them involve equal. Every constraint in linear programming has an equal. Either less than equal, greater than equal, or equal. And when we start getting to the software next week, or the week after, I can't remember, next week, it assumes the equals there. When you're entering the details of a constraint, you're either putting a less than or a greater than. You don't have to put the equals, it assumes the equals with it. And if you put in equals, it just means equals. So it's less than, greater than, equals, but really means less than equals, greater than equal, or equal. Okay, now, an objective function never, ever, ever, ever has an equality. Never has the less than equal, never has a greater than equal, never has an equal. And that right there is one of the most common mistakes I see every semester on objective functions. Excuse me. So no equalities on objective functions. It's a max and then a mathematical equation or a min mathematical equation. But the constraints always have a less than equals, a mathematical equation that involves the less than, greater than, or equal. Okay, we got that. Now, as you read a problem, a way to say to yourself, as you're reading it, did I just read something that might be a constraint, or did I just read something that might be an objective function?
What you're looking for is, whatever it is you just read, is it some kind of limitation? And machine department 2 only has 112 hours available for production. So whatever products are going through department, whatever I just said, 2 I think, you got to put less than equal 112 hours. That's a limitation. I think we're going to see a problem that says, however many of these products you're going to produce, when you schedule product 1, we already accepted a contract for an order of 90. Okay, that's a limitation, even though it's not a less than equal limitation, it's a greater than equal, because however you're going to produce scheduling, product 1, we've already committed to a customer for 90 of them. So when you're scheduling product 1, it's got to be greater than equal to 90, because the sentence said we have to provide them, we have to fulfill this contract. So however we're going to make a product 1, it's got to be greater than 90, equal or greater than, because we're going to fulfill the contract. That's a limitation. But if it says, and the company wants you to design a schedule that will gain the most profit possible, that sentence is an objective function. It's not telling you a limitation. It's giving you the direction that this whole problem wants to take, which is maximize profit. Usually objective functions are referring to costs and profits or revenue, something like that. So hopefully it's obvious. Some are not so obvious. Sometimes it only gives you the information, and you've got to relate it to an objective. Are you ready? We're going to try our first one. And if I remember tonight, I'm going to post these for you to use as study. Where is it? No, not that one. This one. You ready? For the first quiz, I am giving you how many variables should be used, what the variables are, and what they mean, what they're representing. After the first quiz, you've got to get to the point to where when you read a story, you can tell me how many variables are going to be. You decide what the variables are, and you have to define them. And you can use any letters you want. I'm using an X and Y. It's up to you. I hope there's different variables for every person on the second quiz. But you have to be able to read this and get familiar enough that you can determine what the variables are. So to start with, I am telling you there's 2 variables in this problem. And when we're reading the problem, you'll easily be able to see we're trying to determine the very best order to put in for the materials we got to use for next week's production. And the material in this case is sugar. So we have suppliers of sugar, and we're looking at 2 different suppliers. This variable X represents, now this is important, the number of units from supplier 1. This variable Y is the number of units from supplier 2. And the reason that's important, it does not represent how much we're going to spend with supplier 1, it's how many units. So if I had to write an objective function or constraint, if that mathematical equation is talking about the number of units, I'm using X and Y just as they are. But if that equation is talking about money, I got to figure out a way to turn these variables from units to money. And if this, let's say, is how much we're going to spend, well, I got to multiply the units by the cost for each unit to turn it into money. So you got to be aware of that as you're writing these, how to use these variables, because right now, if you're using them all by themselves, they represent how many, the number of units. Let me start, and then we'll stop, and we'll try to put it together so you put it all together what I just said. We know there's only 2 variables. Don't make up other variables. Someone's going to do it on the first quiz every semester. There's only 2 variables. Don't start making up other ones. They're given to you. I'll even give you slack. If you accidentally didn't use X and Y, I'll be okay with that. But don't start adding Z's and T's and F's. There's only 2 variables. The candy manufactured buys sugar candy from 2 suppliers. One called sugar supplier 1, one called sugar supplier 2. The candy manufacturer, that's us, needs at least 55,000 units of sugar. Stop. Objective function or a constraint? Constraint. Because it's a limitation. A limitation doesn't necessarily mean less than equal. It could be greater than equal. And in this case, we know that we need for production minimum 55,000 units. I need to write a mathematical expression that shows that limitation and refers to using these variables which say The number of units we're buying from the supplier 1 is what the X represents. The number of units from supplier 2. I'm putting the variables, thinking about it. I need to buy less than equal, greater than equal, or equal to 55,000 units. Greater than equal. Here's my right side. 55,000. This is in units, and sometimes, you don't have to do this, but I sometimes write units just to remind myself, because I always start on the right side when I write this. Now, on the left side, I got to think, okay, this represents all the units we're buying. We're buying from 2 suppliers. So the left side's got to be all we're buying from those 2 suppliers, which in this case happens to be X plus Y. All we're buying from X, all we're buying from Y, added together, better be greater than 55,000. That's what that says. That's how you turn a sentence into an equation. That's the constraint right there. Hypothetically, I'm just going to say the sentence a different way to show you the change. The company knows they have to buy $55,000 of sugar or more. Okay. Nothing's changed except for this is now in dollars. But these are how many we're buying, not dollars. I got to go back to the story and go, okay, well, how much is it going to cost us? It says supplier 1 sugar is $5 a unit. Supplier 2 is $4.50 a unit. So I would put $5, and this one I would put $4.50. $5 times however many we're buying from the first supplier, plus $4.50 times however many we're buying from the second supplier, has got to be greater than or equal to $55,000. Now, we just wrote a constraint, hypothetically, if the sentence happened to have been in dollars. You see how to do this? I'm introducing you, I'm bringing this down to a level that everybody don't, and right now you're going to read this, and half of you probably already know exactly how much sugar to buy from each supplier. Because it's just that easy. You got to remember, what you're being introduced to is so micro, so small compared to the real world. This is all about just getting the fundamentals down, how these are used and how they are created. Most of the time you have like 50 constraints. We're going to have, I think, 2 or 3 constraints. And sometimes you have 10, 20 variables, not just 2 variables. And there's no way you can just read it and do it in your head. You literally got to do the math. And in the old days, we used to have to graph this and figure out where the lines are going to meet to find that optimal solution. So, anyway, you're just getting the function. So here we go. It's not in dollars, it's in units. X plus Y greater than or equal to 55,000 units is one of the constraints. Next sentence. Supplier 1 can supply up to 36,000 units. Stop. Objective function or constraint. Yeah, that's a limitation. Less than equal, greater than equal, or equal. Less than equal, 36,000, is that correct? 36,000, and that's units? Not $36,000 worth, right? Units? So the left side's got to be in units. I need variables or something here that represents, that will say to us, supplier 1 has to be less than or equal to 36,000 units. There's already a variable, X, that represents the number of units from supplier 1, so we'll just put an X there, less than or equal to 36,000 units. That represents supplier 1. The next sentence says, supplier 2 can supply up to 26,000 units. Pretty easy. Same thing, less than or equal to 26,000 units. But it's the other supplier. It's in units, so I don't need to multiply Y times anything. Y says the number of units from the second supplier, less than or equal to 26,000 units. Then it says the price per unit of supplier 1 sugar is $5. I don't know if that's a limitation or what. I'm just going to keep reading because I'm not sure here, right? I'm pretending like I'm not sure. And the price per unit for supplier 2 sugar is $4.50. And then it says, this is just additional information, I guess. And then it says, write the objective function and constraints to solve how much sugar should be purchased from each supplier while keeping the cost as low as possible. Objective function, max or min? Min. Absolutely. Min. Matter of fact, the objective says to keep the cost as low as possible. Now, we have to write a mathematical equation that represents trying to keep the cost from what we're buying from these 2 suppliers as low as possible. minimize however many we're going to buy from X1 times the price of $5 plus however many we're going to buy from supplier 2 times the price of $4.50. There's the total money we're going to spend. That's what we want minimized. No equal anything, no less than equal, no greater than equal. It's a mathematical equation that you want minimized because it represents cost. There are 3 constraints, 1 objective function, 2 variables. That's how you write a linear program. We would then enter this into the software. We let it know it's a min. It will ask us how many variables do we have. We'll say 2. It will label them, I think it goes X1, X2. We'll just type real quick, change the X2 to a Y if we want, or leave it, it's up to you. All of a sudden, it'll be asking you what numbers are with the variables. In the objective function, you'll put the number 5 underneath the X, the number 450 underneath the Y, then you jump down to the constraints, wants to know what numbers are with the variables for each constraint. The first one, this 55,000, what's with the X? A 1. What's with the Y? A 1. Then it asks, is it greater than equal, less than equal, or equal? You just type greater, it assumes the equal, and then you type 55,000. You go to the next one. Underneath the X, you put a 1. Underneath the Y, you can leave it blank or put a 0, because there's no Y. Leave it blank or put a 0, then let it know it's less than, then put 36,000. See how this goes? So then you have to formulate these, enter the details, click OK. It will solve it for you. It will tell you exactly how much you should be ordering from the supplier 1, exactly how many units from supplier 2, and it calculates this, which is called the objective function value. It will plug in the optimal order for X and multiply it times $5. It will put in the optimal order from Y and multiply it times 450 to show you exactly how much you're going to spend for that optimal order, which will be the least you'll have to spend to meet all these requirements that you're talking about here. And that's as low as you can get. There may be an alternative solution, but it won't save you any money. It'll either be the same amount of money it costs or more. That's just the lowest you can get it. That's what linear programming does. Stops companies from wasting money. Throwing money away, which is so common. Until the company gets so big that they can afford to hire people, you know, they have time to do this stuff and keep their costs as low as possible. So it's the smaller companies that actually. You ready for another one? You ready? Gets a little harder. By the way, this was so easy. You tell me how. Oh no, you can't. Go ahead. I'm sorry. Go ahead.
So if that was on the quiz, though, would be the only 4 things you would.
Yeah, I'm not asking you to solve it whatsoever. If this is on a quiz, I'm going to ask you to write an objective function and a constraint, and I'm giving you the variables, and it will say x1 equals number of units from supplier 1. I'm sorry, not x1. xy equals the number of units from supplier 2. You write this and these 3, and that's what I'm asking for. You got to pick out the information from the words. And there may be a question where I'm only giving you one sentence, and you just write the expression. I'm telling you what the variables represent, and then you write. Don't let that trick you. I want to say that again. There may be a question where I'm asking you to write just a constraint, and there's only one sentence to work off. It's not a whole problem. Just a sentence. It may be like, the candy manufacturer gets sugar from 2 suppliers. X is the units from supplier 1, Y supplier 2. Write a constraint for this sentence. The candy manufacturer needs at least 55,000 units of sugar. And that's all it will say, asking you to write the constraint using the X and Y. But there may be another sentence, and it may say supplier 1 can only supply 36,000 units. Then it says, write the constraint for the first sentence. The second sentence has nothing to do with it, and you just ignore it, and don't let it fool you, because so many students will go, oh man, that 36,000 must go somewhere, so they'll just put it somewhere in the constraint when really it wasn't used at all. You know, so don't let that fool you that there's more information than you need. That's possible. If I'm only asking for one sentence. By quiz 2, you're getting full problems where you're writing out this whole thing and solving them. By quiz 2. So quiz 1, maybe just a constraint, maybe just an objective function, or if it's as easy as this and the next one you're about to see, it may be the whole thing then. I actually have 3/4 of the quiz written, waiting to see how well we do on this part. So that's the only part I got to write still. When's your quiz again? Is it Saturday or Sunday? All right. All right.
Here we go. You ready? Call me out, I'll show up. You ready? You're a finance major. You go work at an investment company. You have this client come in, the weirdest thing, and said, here's $50,000, and the client says, I want you to invest it for me, but for this first $50,000, I only want you to decide how much goes into each of these two companies, and then if there's any money left over, just put it in a money market fund or something, you know, with the scraps. But as much as you can, as much of that $50,000, I want you to invest in either IBM stock or Netflix. And so this is your hands are tied, but you decide what's going to be the optimal way to invest this $50,000 in these two stocks to try to achieve some goal for the client. Let's read and figure out what the goal is. The goal would be the objective. Okay? The client says $50,000 should be invested as an initial investment strategy. The client would like to restrict the portfolio mix to these two stocks. IBM selling for $160. Estimated annual return of about $8 a share in a year. Maximum possible investment. For some reason, the most we could probably put in there is $42,000, whatever the reason may be. Netflix, $130 a share. Estimated annual return about $7. And the most we can put in there is $38,000. Just looking at the most we can put in there, and we have $50,000 to invest, we're for sure getting involved with both stocks. It's not all going into one stock. And that's probably why these maximums are on there, just to make sure we don't pick all one stock. If we could put it all in one stock, and the objective is to maximize our annual return on the investment, our annual return percentage, all right, in dollars even, same thing. Which one would you pick, IBM or Netflix? Which one's going to give you more? Okay, now, if you're a finance major, I want you to check yourself, because anytime a decision's made on which one to invest in and which one's better, you must convert it to what percent you'll make of your money. Because you can buy so many more shares with your $50,000 at $130, that even though you're making less with this, you will come out ahead. So always, always think about it before you just jump on $8 a share will get you more. You can't get nearly as many shares. Look at it carefully. What percent will you make? $8 divided by 160 has got to be lower than $7 on 130. That's got, and you always go with the higher percent. All right, here we go. First thing I want to do is figure out what it is we're writing. It says, write an objective function, assuming the client desires maximizing total return on dollars. There it is. There's the objective. Before you even read, let's write it. Is this a max or a min? Max. There you go. All right. What variables are given? Y is not how much we're buying in IBM. It says number of shares. X is number of shares. Y is the number of shares of IBM and Netflix. So we're doing a max, you said. I know both variables involved, so I know IBM, Netflix, it's added. Does it say that we want to maximize the number of shares bought of IBM and Netflix? Because if so, we're done. But it says we want to maximize the total return. We have to take these variables, which is the number of shares, and somehow do something to them to represent the total return of the, of this investment. What do we do with the X? Yeah, multiply it by 8. You want to multiply it by the amount each share would provide in annual return, which in this case is $8 a share. So now however many shares we're going to recommend to buy, times $8 of return. The other one is $7. And now there's the objective function that represents maximizing the total return in dollars. We had to turn the variables into dollars of return. That's estimated. Next sentence says, and on a quiz, I won't be this obvious. It won't say you have 3 constraints. You got to figure out how many constraints you have. And it will say total invested funds available is going to be one of the constraints. Up here, it says the client is requesting the firm handle $50,000. You're the investment advisor. You're writing a constraint less than equal, greater than equal, or equal to $50,000. I heard two answers here, and they're probably both correct, but take into consideration, you may not be able to invest every penny of the 50,000 on those two shares unless there's a way of buying partial shares, right? So it won't be exact. So let me hear again, less than equal, equal, or greater than equal? Yeah, it's got to be less than equal, because you probably can't invest every penny. So less than equal, I can see equal in some cases, but in this case I think it's less than equal. Logic says we may not be able to invest every dollar. And then this is in dollars. And just to remind myself, I'm putting a dollar sign. So this side, which this is about our total investment, so it's going to use both variables, because both variables are what we're investing in. So I know there's an X, and I already know it's going to be added to Y, but I need to convert X and Y to represent $50,000 that is being compared to. X and Y is how many shares. What do I put with X to convert it to money? I heard 160 is what we're going to spend to get the number of shares that we're going to buy. And then what do we put with the Y? $130 times however many Netflix shares we're going to buy. There's our constraint equation. Next it says maximum IBM investment. Yeah, it says we can only invest $42,000. Putting the 42,000 here. I'm reminding myself that's dollars. Less than equal, greater than equal, or equal? Less than equal, because it says this is the most we can invest. We can't invest more than that. We have to invest 42,000 or less if we're going to go with IBM stock, which we're going to have to. So this side is only about IBM stock only. The variable that's about IBM stock is X. So something, but X is how many shares we're buying. This is how much money we're going to spend. I got to convert X to money, which is how much does it cost? 160. $160 times however many IBM shares cannot go over $42,000. There's a constraint. Why is not in there? Because it doesn't represent it. The last constraint says the Netflix maximum investment, which happens to be $38,000. Hey, there you go. And this is also in dollars. Less than equal, greater than equal. It says maximum investment, so less than equal. The left-hand side is what variables that represent the sentence. Maximum investment in IBM. Wait. No, it's maximum investment in Netflix, so it's going to be a Y. Y is the number of shares. This is $38,000 in dollars. I got to multiply Y times its price to turn it into dollars, which is 130. There's 1, 2, 3 constraints, 1 objective function. It says there's going to be 3 constraints and 1 objective function. We're done. A little hard, but still easy, right? When you figure it out. Again, on your first quiz, very common mistake is leaving off the max min or adding the less than equal, greater than equal, or equal with an objective function. Common mistake. Go ahead.
Is it safe to say that however many variables you have, you'll have one more constraint? Or is that not always the case?
No, it's almost never the case. That was just a coincidence. Almost never the case. There's almost always way more constraints than there are variables. Yeah. We're starting out with just 2 variables for this whole beginning to keep it easy. As easy as you can. Don't worry, once we start using the software, the problems get bigger and more complex, and you don't have to figure out how to solve it manually. You just solve it on the software or using Excel. Do you feel that if you had part of this problem and you had to write a constraint that you could do it? You feel you can? All right, but you got to remember, you got 5 days to your quiz. I can't tell you how hard it is to keep this all straight for 5 days if you're not a numbers person. So have really good notes. Obviously, I'm going to post the video tonight. Hang on, what am I doing? I got more. I'll put another one. I almost forgot. This one's so confusing, I almost want to skip it. But I'm going to lay it out, kind of make it, oh, I almost forgot. You guys, I caught this on my camera. Tell me what you think this is. You ready? Can you see this? Watch. Yeah, don't say anything then. You see it? Dang, it's too dark. Let me turn the lights down. You can't see them. Yeah, how do you turn this off? You ready? Hang on. Let me start it again. Okay, ready? Ready? There you go. What is this? Look at, you see it? There it is. Where are they going? Is there a meeting up there? Huh? Where are these guys going? Anybody? What's happening here is your infrared security cameras, which this is a brand new one I've been playing with, is picking up micro particles that are riding the waves of air. If you've ever seen like an undersea documentary where they turn on that big floodlight and you see all these things all over the place, that's exact, you know, really humans are living under a sea. I mean, there's particles all around us as we speak. You just don't see them all. And we call it our atmosphere, but it's no different than, that's what a fish would call where they live. That's their atmosphere. I mean, to them, they're just breathing and riding the waves. Well, there's waves all around us. And there's particles riding the waves just like you see. And the only reason that was able to happen is I had just left the room, which stirred up the air a little, and that's what's causing the particles to rise. They're riding the upward. So I don't want you to think there's ghosts in case you see something like this. I just thought it was interesting. You ready? Where are we? What is this? Okay, this is it. It's called the ironworks. But to simplify it, I'm going to move it over here. I'm going to take this. I put together this, and if someone reminds me, I don't remember if I posted this, but I should. Over here is trying to get you to see how to write linear programming constraints and objective functions using variables for everything. But I find the stories will never be that way. They'll always give you the numbers for certain things, except for what the decision has to be made on. Remember, the variables always represent what decision has to be made. The rest of the numbers will be given to you. So as we read this, when it's not giving us a number, I'm going to go over here and get the number. And we're going to write some constraints based on that, and objective function. And to start with, since this is chapter 1, I'm going to give you the variables. X1 is the number of product ones that are scheduled for production on the next production schedule, and X2 is the number of product 2. All right? Ironworks manufactures 2 products made of steel, and we just received this month's allocation of 200 pounds of steel just arrived on our dock. Big giant roll, 2,000 pounds of it. Stop. Objective function or constraint. Constraint because we cannot schedule production that's going to use more than 2,000 pounds of steel. Our production is limited. If there was more than 2,000 pounds of steel, it might say, and a carryover of steel from last month's production of another 150 pounds. Still, it's a limitation. We cannot schedule more than 2,150 pounds then of steel for production. So this is going to be a less than equal, greater than equal, or equal. Less than equal, 2,000, and this happens to be pounds, which is our units. Units are in pounds for the story, so there's our units. The left side has to represent the total number of units and the steel they're going to use so that it doesn't go over the 2,000 pounds. So we need to read to see how much steel each one of these things we're about to produce would use. Whoops, it takes A1 pounds of steel to produce product 1 and A2 pounds of steel to produce product 2. Product 1 uses 2 units, so 2 units of steel. Product 2 is 3 units. Over here, what are my variables? X1 and X2. Here's X1, here's X2. I know they're added together. But what number goes here to represent how much steel they're going to use? This is just how many of them we might produce. How much steel does product 1 use? I missed it. 2, so 2 pounds of steel times however many product 1 we schedule, plus how much steel is a product 2 use? Is it 3 or 1? 3? Just one more than 3 times however many product 2 we schedule, add them together, it's got to be less than 2,000 pounds. There's the pound. Next it says, let X1 and X2 be this month's production level of product 1 and product 2, which we did do. There's X1, X2. It says denote P1 and P2 as the profit contribution by these 2 products, X1 and X2. Up there I put product 1 will yield $100 profit, product 2 will yield a $200 profit. The first facilities are such that the most blank units of product 2 may be produced monthly. It's something has to do here with a facility capacity of product 2, and product 2, no more than 720 units is the capacity. I want to do that one real quick. Less than equal to 720 units of product 2. Is that right? Product 2. Less than equal is because that's the most we can make, and it's only saying of product 2. I have to use the variable for product 2, which is going to be x2. I don't have to put anything with it because x2 represents the number of product 2 we're making. So x2 less than equal to 720 is the most we can make of x2. If we decide to schedule any x2, got to be 720 or less. Then it says, where am I at? Right here. The profit, we skip the profit for a second, trying to figure out how that's used. We have a limitation on productivity, and then, hang on. There we go. Then it says the total, it jumps right into everything. That's it. So the only information we didn't use is the profit contribution, the $100 and $200. Well, how do we use that? Well, come on. Constraint or objective function, maybe. There we go. Max or min? Max. I skipped something. I got to figure it out in a minute, maybe. Max, because it's all about the profit. It didn't come right out and say we're trying to maximize the profit contribution. It just told us what the profit contribution is. I think on the next slide I might mention.
Don't we have another constraint?
We do.
Contract order.
That's right. I skipped that sentence. I must have accidentally went past it, and I know it's there. Is this it right here? There it is. I accidentally went past this sentence. Ironworks has a contract calling for M units of production 1 this month. I use that as an example when we were talking about it earlier, where I said, hey, if you have a contract in place and you accepted that contract and you have to meet that contract, no matter what you're producing, you got to produce enough to meet to make that contract. It's only a contract for product 1. The number of product 1 we're going to make is X1. I'm going to put it right here. And it has to be less than equal, greater than equal, or equal to the contract amount. That's right, greater than or equal. We can't go less than. And how many did I say we got to make for that contract? Is it 60 or 60? Okay, 60. There it is. X1, the number of product 1 we're going to make and schedule, has to be greater than or equal to 60 units. To meet that contract, that's 60 units. Now the objective function is the profit. We're trying to maximize it. There's X1 and X2. There's no equality, but we got to turn this X1 and X2 as to how many we're scheduling to the profit contribution. The profit contribution for X1 is how much? I can't hear you. $100? Okay. I see the profit for 2 is 200. There's our objective function. Maximize however many X1s you're going to schedule times $100 profit, however many X2 you're going to schedule times $200 profit. I want to tell you how this is so easy. You can probably do it in your head. Look at the profit contribution. Without looking at these limitations, would you try to schedule X1 or X2 based on this profit if that's what you're maximizing? As many X2 as you can, but you've got a contract in place. And it says we got to schedule at least 60 X1s. Based on this profit contribution, as I look at these other limitations, I'm probably only going to make 60 X1s. Because look how much more, if the orders are there, I'm going to go ahead, even though we haven't accepted a contract yet, I'm going to make as many X2s as I can. And let me look here. That's it? 2 more? We got the 60 in place. We got the, how many units of steel, how much steel is available. So really the steel limitation is the one that will hold us back. How much, if we do 60 right here, 60 times 2, all right, equals 120. We have 2,000 units of steel, that's 120 units. I subtract that from 2,000, that 880, 800, what is it, 1,880 units still left. Divide that, how many units will number 2 use? 3? Divide that by 3, somebody, and tell me what you get. 8, how much? 626. So Y, I'm going to probably make 626. Now what I just did in my head to figure out what my production schedule is going to be next month, taking into consideration I'm maximizing that. Oh wait, did I go over the limitation? No. Realizing I can only schedule up to 720, so I didn't go over that. I went to 626, and realizing that this 2,000 is kind of dictating how many I'm making, because I know I got to fill the contract of 60 of these, but the profit's so low, you know. Get it? What I did in my head is what linear programming does. And yes, this problem's so easy. This is starting out to where you guys can do these in your head. But trust me, we're heading to where there's no way you're going to do your head. It takes so long where you could have these complex problems done in seconds using software or computer, but how to set them up is what the key is. You make one mistake on setting it up, you're not getting the right answer. You're getting wrong information because you put in wrong information.
After we made all of product 2, we had 2 units of raw material left over. Would we make 61 of product 1 since it was like
Possibly. We would know in advance because we know exactly how much product's going to be used when we put the schedule together. And then we'll go, oh, there's that much left. We could sneak in one more product 1. Why not? Yes. If it's using the same machine, that's really important because you want to do your switch over. You don't want to switch back to do that last one. But if it's using 2 different machines, it's not even that important. They just go, you don't need them. Any questions on the quiz and what to expect and how it's going to go? Try to sit somewhere. Usually don't sit. All right? Don't sit in your usual spot for the quiz. Go back. I know that it's hard on a lot of people. But there's a couple students coming from the other class, and so they may already be in your seat anyway. So just everybody sit wherever they want. I'm going to use folders between each of you. A couple people have had me before. They know what to expect. Go ahead. You can. You have to have everything on Blackboard open before the quiz starts because you got to turn the internet off. You can't turn it on to go get things. Open up all the PowerPoints, open up the answers to all the homework. What else is posted? Anything is posted. Get them all open. Turn off your internet. They're open now. You can use them. And then I'm walking around. You guys show me you're on airplane mode on your phone. You have the internet shut off before anybody gets their quiz. Say again. Right now, it's heading towards 50 minutes. I'm trying to get it to an hour time. And I know the class is an hour, 15 minutes. Listen, this quiz, your only challenge is going to be time. And that's why it's a time quiz. It's open book, open note. The challenge is going to be that it's time. So you've got to be familiar enough with where to find things that you can choose a quiz in time.
I might have missed it at the beginning of class, but we are allowed to use our homework as examples.
The homework answers is what I rely on instead of your own homework. Only because if I didn't do a detailed grading, you know, if you haven't compared it to the right answer, I didn't compare it to the right answer, so I don't know if it's exactly correct. So I usually would open up all the answers that are posted and use those as my guide instead of my own homework, really. Unless you have extra notes on your homework compared to what's posted. Yes?
For the sake of time, I noticed that you mentioned you're going to pull questions from the reading, but I know we discussed your most online testing is going to go over in class. Should we read it for the sake of time, or is it stuff that we can look up?
Well, it's stuff you can look up, but I'm not going to teach you lookup skills, but I hope you guys would be able to pick a main word out of there, start looking in the index in the back, and try to get to a page number fast, if that will help. Personally, I don't reread, but because I know I can find a word that will lead me to the right spot, and I'm good at scanning for words to find the spot that will help me with that question if I don't know the answer. I'll usually read it and let my gut lead me to 2 of the choices, and then I'll start looking for which one's really the best answer. That's how I kind of do it. If we all could memorize everything, we'd all be doctors. Because that's the hardest part of med school is memorization. That's the hardest part. More people drop because of not being able to memorize the human anatomy and physiology, things they force you to memorize. You have to. I'm all about you being able to have the skills to find the answers quickly to this kind of stuff and not have to memorize it. And understand how it's used and understand how it's calculated. Because I had done a whole bunch of computer programming, when I was in my career, all the time we have to meet with programmers. I worked in accounting. I was overseeing business and the companies, the business part. And when we meet with programmers, understanding how programs were written, understanding how coding's done, understanding the logical steps, and what are those? It's been so long. Those charts you put together as to how the logical process takes place was a real benefit for me when we had those meetings with programmers, because we were always trying to get programs written to do something that can't be done yet
with the with the computers at work, something a department wants to do. And for the programmers to truly understand it, that was kind of my niche, is that I could literally take what we wanted to accomplish and communicate to them how the code would be written, the logical process, so they would understand it. And then they'd go, oh, and then they'd go and rewrite. Back then it was like PS, you guys never heard of language, before C even came out. Yeah, before. It was after Pascal, after COBOL. I can't think of it right now, it's been so many years. But being able to communicate it that way was kind of my niche. So understanding how these are calculated will be your niche, that when these are being communicated to you as to, you're working for a manufacturing company, here's why we're going to do this and this, because of this calculation, you need to be able to understand, or you're going to be at that meeting faking it. And everybody's going to know it, except for you. You're going to think no one knows you're faking it, but everyone's going to know you are. You've got to understand, no matter if you're a human resource major, marketing, finance, accounting, you need to understand how things are done in all the departments, because when you get to the table, when you get into upper management, you've got to have these conversations with every department. This is how I learned about how marketing always spends every dollar. How marketing always thinks you'll sell 1 million of them. Because I was at those meetings, always meeting with different marketing people, and they all have the optimistic philosophy. And I'm more of the voice of reason at the table that says, wait a minute, what if we only sell 250,000, not 1 million? We got to prepare for that worst scenario. I always say, prepare for the worst, hope for the best. And you don't get caught then, whoops, I'm out of cash, can't meet payroll. That puts a company down to the count. You misestimate things, and all of a sudden you're running out of cash, and either you guys start laying people off, or you can't make payroll. You don't have something you can use collateral to quickly get a loan to make payroll, you're done. It's just a matter of time. Employees hate you, and you're almost done. Just a matter of time. It's such an employees market right now that you're going to be done faster than usual, because it's so much faster for an employee to find another job. If this market stays the way it is, and you guys get to graduation within a certain period of time, you're probably going to have the easiest job finding activity of any graduating class in history if this keeps going the pace it's at right now. And it will eventually crash, and I hope it's after you graduate and get that job. Because it will be back to an employer's market where when I was a manager, where I would advertise for a job and receive a stack of resumes from here to here, almost always, and go through them, and without even looking at anything else, I had to separate those who have degrees and don't have degrees, which is really the main reason why you're in college, so you don't get separated into the pile with no degrees and never get a chance to sit across from someone and say, hey, I can do that job. You don't want to be that person. And that's why you're here. You got to hurry though, because this market, you're going to get the highest paid job you can get out of college if you can get this done fairly soon. That's how the market is right now. It is an employee's market. It's the most I've seen in decades. All right, that's it. Here's the sign-in sheet I sent around. Where did it leave off? You didn't sign in. Get to it and sign in. Be ready for Monday. I'll see you then.
Is there homework for today?
No, your homework's to prepare. I'll hopefully remember to post